Victor White here, and today we'll be looking at the two-sum algorithm on Leetcode. This question says, given an array of integers nums and given an array of integers nums and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. So, looking at this example, you'd see that given an array of 2, 7, 11, 15, and a target of 9, what two numbers would you add up here to give you the target of 9? So we can already see that looking from this, 2 plus 7 will give you 9, and the output of that will be an array of the indices of those numbers, which is 0 and 1. The same thing goes here. If you look at here, if you add 2 and 4, you get 6. So the output will typically give you 1 and 2, which are the indices of both 2 and 4. So a two-pointer approach can be used here to achieve the given result. So looking here, for instance, you can set one pointer to this value, which will be the first value in the array, and then you check against each other element in the array using a loop, right? And check if the next element, adding the p2, which is the value of the next element, to p1 would sum up to target, right? If it does, then you will just return the indices of those numbers. If it doesn't, you go to the next one until you completely iterated through the array. If when you have gone through the array and you did not see a value, then you would reinitialize p2 or p1 rather to the next element in the array and redo the entire loop again. That's a brute force approach to this problem, and we are going to code that out now. Um, Afterwards, we will then see ways we can optimize our solution. So the first one is to, like I said, initialize p1, which is the first pointer to the array, which would start off at the first element in that array. So while the p1 is less than the nums array dot length, just the condition to break free from the array. Okay, so here then the number to find would be the target minus the nums of p1. So what this means here is you're on p1 is 2, so the target is 9, so 9 minus 2 will give you 7. So you trying to see if you can find 7 in the remaining part of the array. If you find 7, then you will just return those the indices of those two values. If not, you would keep going through the array and updating p2. If you run through the array and you didn't find 7, then you would move on to the next element and redo the entire iteration again from the point of p1 to the end of the array, right? So the number to find variable here, then you would go into another for loop where you would initialize p2 to be p1 plus 1. So this is the next element in the array, right? And this p2 obviously would run only when it's less than the length of the array. And you would also be increasing p2 plus plus. Here, then you check if the number to find is equals to the nums array at p2. If it is, then you just simply return p1 and p2. Obviously, if none of this works, then let's just return null here. But this is a solution, right? So you loop through this, initialize p1, check if the p2, which is going to be the next pointer here, is equals to target minus that value. If it is, then definitely it should sum up to give you that value, and then you just return it if it's correct. If not, you keep looping through it until you find it. If you didn't find it in this first iteration, then P2 is going to be updated to the next value, and then you move through this array, right? So if you run this, let's quickly just do a run and see. Yeah. So if you run this, you see it passes, and that is a solution to this array. But can this be optimized? Currently, if you look at the time and space complexity, the time complexity for this would, obviously looking at this, will be um O of square time, right? So like O raised to the power 2 time. Why? Because you have two for loops there, and the worst case is that you would be touching every single one of the elements in the array like 2 times. There are two for loops that are running concurrently. So the first for loop is going to run for the P1, and then there's another one that gets run to find this number to find. So this iteration is going to run O of n time, right? And this second one would also run O of n time, making it a time complexity of O of n square. So the space complexity of this, there's really not scaling space going on here. So the space complexity of this is O of n time, or O of 1 time rather, right? So to optimize this, there are ways you can optimize this using a hash map. We can use a hash map to optimize the solution. Let's go ahead and initialize the hash map and call it nums map, right? And then go into the loop, but this time it will just be one for loop that will be initialized, the first element in the array, of course, while that value is less than the length of the array. Keep increasing that value by 1 each time you run through the map. So now the current map val, and I'm going to explain this in a bit, would be the nums map nums of p. So when you run through this iteration the first time, this current map val will be undefined. Why? Because you are trying to look for a value in this nums map hash map that would not be there, because at the first point this is going to be an empty hash map, right? And nums map here would now be nums at p, which will be 2, given using this example, of course. So here is going to be nums map index of 2, or rather you're looking up this hash map if it has any key of 2, right? But it would not, because it's going to be empty. So this current map val is undefined. So we can do something with it. We can check if this current map val is greater than or equals to 0, right? So if there is there a value in the hash map? If there is, then definitely we have found it. We have found our indices, because current map val now, we can simply just return the current map val and p. So this means we have found a value in the hash map, and that value will be the indices of that hash map, and that part will be written here. So if this fails, then we just simply want to set number to find, which should be the target, again from the previous solution, the target, then the nums, the p array, the nums p, right? Then we just want to set nums map to be number to find and equals to p. So when the loop happens the first time, we will be nums map then becomes 7, which is what this number to find variable would be, and the value will then be 0, right? So this 0 is the index of p at that current time, right? So when this loop then goes on this the second time, so p now becomes 1, current map val here will then be, so current map val when p is 1, when p is equals to 1, this nums map here would now be nums map of 7, right? So nums map of 7 would have a value of 0, so current map val here will be 0. So since current map here will be 0, current map val, since it is greater than or equals to 0, so this if statement will be true, and then it's just going to return 0 which is this, the value of the of this, and then p at this point will be 1. So you have then found your solution, right? If we run through this again using this one, the first time this would run, right? Current map val will be nums map of 3, which will be undefined because at this, the first iteration, nums map will be empty. So this will be undefined, and at this point, this if statement will be false, and then the else statement will fire, and the number to find then here would now be targets, which is 6, minus nums of p, which would be 3. So numbers to find here will be 3. Let me just get rid of this. So then the nums map will then be 3, and the index p at this point will be 0, right? So then if you go through again, p becomes 1, nums map of 2. So this is nums at p, which is going to be the second element there. 2. Is there is would there be any value to in this hash map? There would not. We only have a 3, so this would be undefined as well, and this if statement will be false, and so this else statement comes in. The number to find here then becomes target minus that, so the target 6 minus 2, which would be 4, right? And then we set nums map into, so this would still be 3, 0, and then there will be a new entry there, which will be 4, right? Nums map number to find 4, and p will be 1, right? So if we go through it the next time, at this point p would now be 2. The current map val will be nums map 2. Is there a value of 2 in the hash map? Or rather, nums map, oh sorry, this is going to be 4, right? So nums, the nums array index of p, which will be 2, will correspond to 4. So nums map, if you look up this 4 key in the nums map, you would see a value of 1, which was what we just initialized at the previous iteration. So here will be 1 if the current map val, which is going to be this one here, is it greater than or equals to 0? Yes, it is. So then we have found our 2 values. What would be now returned here would be the current map val that we just saw, 1, and p, which is 2. So in the situation, we have found a value. So we just really typically need to iterate through the array one time, and we'll be using a hash map to just store the number we're trying to find and the index of that current iteration, and so that if we find that number in the hash map at any point, we just return, and then we have our value. So the time complexity of this is comes down to O of n time from O of n squared that we had previously, but the space complexity is scaling at this point, so that becomes O of n, because the hash map could the worst case scenario would be that the hash map would just keep having elements being added at this point up to the size of the input array, right? So it has scaling space, but the time is slightly better from O of n squared previously to O of n time. So this is an optimal solution to this. Let's just run this and make sure it works and I have not made any errors. Let me just run this. Okay, so it still passes. So this is an optimized solution to it. Hopefully this helps someone out there. If you like this video, please leave a like, subscribe to get the next algorithm and data structure solution that I'll be putting out. Thank you. I'm really also open to criticisms and feedback, if any. Thank you, and see you in the next one. Bye.